Hello everyone, and welcome to my channel, Squarewave 2. I recently posted 4 videos about crystal radio receivers and how you can wind the coils for your crystal radio. Well, these videos got such a good response that today I think I'm going to go ahead and show you the next step in the radio building hobby. How about a powered radio with some amplification? No, don't worry. We're not going to plug it into the wall. That will probably come in a later video. But how about a battery-powered regenerative radio receiver with one tube? Well, I have found just the project for you. In this book, Radio Receiver Projects You Can Build by Homer L. Davidson. It has 33 complete radio projects, beginning with a simple crystal radio, going through regenerative radios, shortwave radios, and ending with a real super heterodyne receiver. The radio I want to show you today, which I have just assembled, can be found on page 102. It is a battery-powered radio. It runs on 2 flashlight D cells and 3 9-volt batteries. It's regenerative, and it has one tube. And it works very, very well. It's a simple circuit, and it's worth your while to build. You'll get quite a bit of volume. And it's a little surprising how well it works, because the one tube that Mr. Davidson selected, the 1S4, is actually a power pentode tube. The power pentode tube was designed to be used in the last audio stage of a battery-powered receiver. However, no matter, the receiver works very well. Oh, and if anybody is interested in what I'm doing here, please stay tuned for a brief epilogue at the end of this video, and I'll tell you what I'm doing. Okay, let's see a schematic diagram of the receiver on page 102. And for anybody new to the radio building hobby, I'm going to give a very simplified explanation of how the radio works and what the various parts do. So here we go. Every electronic part has its own special symbol. This symbol is antenna. This is ground. This is a vacuum tube. This and this are batteries. This is a combination switch. Here's what happens. Radio waves of all different frequencies are constantly striking your antenna. They go down the lead-in wire to your set. The first job of your set is to select only one of these frequencies so you can hear only one station at a time. This is done by the tuning circuit, consisting of a coil and a tuning capacitor, also called a variable capacitor. This variable capacitor is the thing with all the silver plates that mesh and unmesh as you turn a shaft. After one frequency is selected, it is passed on to the control grid of the tube. By means of a small voltage on a control grid, a large current from the heated filament to the plate can be controlled. This is where amplification occurs. Then the signal is fed back to a small coil called a tickler coil. Although you can't see it here, the tickler coil is wound on the same form as the main tuning coil. They're only about 1/8 of an inch apart, and they are magnetically coupled. Energy from the tickler coil is fed back to the main tuning coil, thereby reinforcing and strengthening the signal. This is a continuing process. When the signal leaves the tickler coil, it travels along here, through a pair of headphones, and down to the positive pole of your battery pack. And in simple terms, that's the way the regenerative receiver works. It's very interesting to me to see the end results of projects built by different builders working from exactly the same schematic. They often bear no resemblance to each other. They're completely different. And if you didn't know better, you'd think they were built from different diagrams. And this is because a schematic is more or less of a functional connection roadmap. It says nothing about physical layout. You can build your radio on a scrap of plywood. You can build it on a kitchen breadboard, or you can build it on an expensive aluminum chassis. It's all up to the builder. Some factors affecting the outcome are the junk box available to the builder, the number of spare parts he has on hand, his budget for purchasing new parts, and also his skill at design, layout, and building. Let's take a look at the physical layout of the radio whose diagram I just showed you, the one on page 102. First of all, any regenerative receiver has to have a metal front panel. This will shield the tuning circuit from your hand's capacity. Here's my main tuning control with the logging scale. This is my antenna trimmer. This is my regeneration control. And of course we have to have an on-off switch. Up here is something I've added myself. Mr. Davidson doesn't do it this way. I've added a rotary switch connected to different taps on the tuning coil. That way I can select taps right from the front panel. Mr. Davidson does the same thing with a simple alligator clip and a ground lead, but I think this is much easier to use and a little more professional. Okay, let's take a look at my parts layout. You can see that I've used breadboard technique. All the parts are mounted to a 1/2-inch piece of plywood that measures about 7 by 9. And of course I have a metal panel. 2 coils are wound on this form. The little one has 15 turns, that's the tickler coil, and the big one has 108 turns, and that's the tuning coil. Every 10 turns has a tap. Now Mr. Davidson connects the different taps by means of an alligator clip and a grounded lead. But what I have done to make the radio more efficient is connect all of the taps to points on a rotary switch, so I can change taps very easily and quickly from the front panel. Here we have the variable capacitor. This is the tuning capacitor. It's 365 picofarads. This is a double on-off switch. One half of it controls the B batteries, and the other half of it controls the 9-volt batteries. Down here we have a smaller tuning capacitor. This is the antenna trimmer. Here are 2 binding posts. One is red for antenna, one is black for ground. Here we have the 2 flashlight D-cell batteries, and note they are connected in parallel, not in series. We want to preserve the 1.5 volts. Here we have 3 9-volt batteries, and they are connected in series. That gives us a total of 27 volts. Here's something I've added myself. This is a jack so I can easily connect and disconnect my headphones. In here is the little 1S4 tube, and back here where you can't see it is a potentiometer to control the amount of feedback. Too much feedback and the set will oscillate, creating a loud howl in your earphones. Now it's very important that a regenerative radio be very stable. Nothing moves, nothing wiggles, nothing flexes. It's a good idea to build it like a tank. Loose parts on a kitchen table connected together with jumper cables is just not going to do it. I think it's about time for a little demonstration. Keep in mind that this receiver was designed to work with high impedance headphones. Now I realize nobody is wearing high impedance headphones, so I've hooked the receiver up to my little Heathkit Signal Tracer IT12 to act as an audio amplifier. Also keep in mind that this receiver was designed to work with an external antenna and ground, just as if it were a crystal radio. But at the same time, this radio is going to deliver much greater volume than a crystal radio, and it will have much better selectivity. Okay, let's see what we can tune in today. Building radios can be a fascinating hobby, a lot of fun and not too expensive. But once in a while, after you complete your project and you turn it on, it fails to work, or it fails to work correctly. Now don't panic, this happens to everybody. It's happened to me plenty of times. What I recommend is you put the project away for a day or two, come back to it when you're fresh, recheck your wiring, and you will very likely find the mistake. And when you do, it's a great feeling of accomplishment and satisfaction. I have a little hint for you that may help you avoid making wiring mistakes. You should work from a greatly enlarged photocopy of your schematic, something like this. Then you take a highlight marker and you highlight each part as you mount it. Then you highlight each connection, you highlight each wire you add. And when you're all done, your schematic will be completely filled in with colored highlight. I've used this trick on some very complicated projects and it works quite well. That's about all I have for today on radio building. Just don't forget to look for the Homer Davidson book, Radio Receiver Projects You Can Build. It will probably keep you busy for a year or more. That's it for now, folks. I thank you all for watching, and I'll see you next time. Okay, I'm glad you're that curious. What I was working on in my opening shot was the television sweep generator by RCA, model number WR59B, made in 1951, back in the days when televisions were serviceable. Of course, this piece of equipment has been totally obsolete and useless for at least 40 years. Or is it really useless? I wonder. Old tube equipment like this is hardly worthless. It is absolutely full of usable, salvageable parts for the radio hobbyist. The first thing I do is pull the tubes. They're probably the most valuable. I already got $60 worth of tubes out of this signal generator right here. Other parts you can look for are variable capacitors, potentiometers, rheostats, switches, jacks, fuse holders, pilot lights, and even the knobs. You can reuse the knobs on your own project. And don't forget the power transformer. These old babies usually had a big hefty power transformer. That's the big black thing mounted in the corner of the chassis. If you need one today for a project, you will find they are very expensive. When you go to hamfests, swap meets, even garage sales, look for signal generators, signal tracers, and especially old oscilloscopes. Oscilloscopes are absolutely full of tubes, and that's what you want. If you start pulling parts today, pretty soon you'll have a junk box as full as mine, and you may even have enough things to make a radio. Okay, that's really all I have today, folks. Thank you again for watching, and I'll see you next time.